Hey everyone, in this video we are going to use the given information that apparently cotangent of theta is equal to the ratio negative 3/2 and that cosine of theta is less than 0, it's negative, and we're going to use that information to find cosecant theta. So let's dive right in. First thing we're going to do is we're going to take the given information. We're going to use that to draw a triangle, a reference triangle in the correct quadrant with all three sides of the triangle, right triangle, labeled. So how do I figure out which quadrant I should be looking at? Well, for starters, I'm going to look at the cotangent. Now, the cotangent is negative 3/2, okay? So if cotangent is negative, that means we're looking at quadrants 2 or 4. So if cotangent is in fact a negative value, right, that means we're in either quadrant 2 or quadrant 4. Next, cosine. This is going to layer up and get us where we need to be. So if cosine of theta is less than 0, that's another way of saying negative. Cosine refers to the x values, x-axis. Less than 0 means left. So which quadrants are touching that negative x-axis? It's those two over there. That means I want to be paying attention to the quadrant that both of those can happen at the same time. And that would be right here in quadrant 2. So first and foremost, I know I'm looking at quadrant 2. Once I know I'm looking at quadrant 2, I can start sketching out a reference triangle. Theta will always be in between the hypotenuse and the x-axis, and then I will have a point in that quadrant that I will connect to the closest x-axis. And there we have our reference triangle. Now, I also have given to me in the original given information, I have 2 of the 3 sides. How, you may ask? Well, I'm glad you asked. The way we have 2 of the sides is, since we know tangent of theta, so cot𝜃, is opposite over adjacent, that implies that the cotangent, which is the reciprocal, as we see right there on that post-it, of tangent, cotangent then must be equal to the adjacent over the opposite. So I don't want you to connect that negative to the 3 or the 2 yet, because that will depend on other information in just a moment. Some people mix up where the adjacent side goes. If you go over to your reference angle and you kind of trace over that corner and you mark it up as a little angle, you'll see you can draw a little A in that corner. That A means one of those sides that I'm touching right there with the sides of that A is the adjacent side. And then I could take that A apart, boop, like this, and then it becomes an H. So adjacent and hypotenuse, that's the adjacent and that's the hypotenuse. That means that the only side left is the opposite. Since this adjacent is going to the left, it's going to be negative. The opposite's going up, so that's going to be positive. The hypotenuse is always positive. The adjacent is going to correspond with the 3. The opposite is going to correspond with the 2. And again, that negative will go with this side right there, and the other 2 right there is positive. They can't both be negative because a negative over a negative is positive, so that wouldn't make any sense. Now, I have legs of 2 and 3. Does 2, 3 blank make up a Pythagorean triple? The answer to that question is no. That means we have to use Pythagorean theorem to figure out the missing side. If you fill in even the negative side length, it will always go inside of parentheses, and then the square will happen on the outside. That will imply -3 times -3, which will become +9, so you really don't need to put the negative in. Plus 2 squared equals hypotenuse squared. That again is 9. That right there is 4 equals h squared. Do not get in a habit of thinking the 2 sides you're given are always legs. Sometimes it's a leg and a hypotenuse, and you need to put them into the right places in the Pythagorean theorem. 9 plus 4 is 13 equals h squared. And to get h alone, we're going to take the square root of each side. The square root of h squared is h, and the square root of 13 is the square root of 13. 13 is also prime. I cannot simplify it any further. If it were something like 8, 2 root 2, or 12 would be 2 root 3, something along those lines. But 13 is prime. I can't do much more with that. So that right there is root 13. And like we said, always positive. If I wanted to just draw this a little bit out, just a little cleaner to reinforce everything, that's -3. That's +2. This is positive radical 13, and my theta reference angle is always right there. That's what I'm looking at, and I'm looking for cosecant, which is the reciprocal of sine. And since sine, right, since the sine of theta, so cot𝜃, is opposite over hypotenuse, that means what I want is cosecant theta, which is hypotenuse over opposite. So if I look at my triangle, cosecant theta equals, this actually works out fairly nicely because hypotenuse is radical 13. That means I don't need to rationalize my denominator, lucky, over opposite, which is 2. None of those are negative, and sorry if you hear my dog. So we're done. That's it. So if you have anything else you want to add to that, please go ahead and put that in the comment section underneath the video. If you feel good and you don't think you would need to watch this over again and you are marking it off as super duper, give the video a thumbs up. If you're like, I'm not that sure, maybe I should look at this again, mark it with a thumbs down. Click through for the next example. Hopefully that clears up any loose ends. And I hope you are feeling a little bit more confident and a little bit smarter by the end of that video. Adios. Dell said.